I'm going to have a go now at cleaning up some of these blank panel strips. As you can see, they're pretty filthy really. And to do that, I'm just going to dunk them into a bowl of warm water and give them a bit of a scrub with a scrubber and see how they come out. Well, here's one I did earlier on the top side, and as you can see, they scrub up quite nicely. There's a little bit of bobbling on some of them. The rust is just starting to come through. Unfortunately, this has been stored in a garage, and you cannot store this sort of equipment in a garage, or guitar amplifiers for that matter. Absolutely terrible place for them. But I do understand people don't have a lot of room in their houses, particularly for something the size of this. So anyway, we'll plough through and do a load more of these and get them all up to scratch. Right, they come up quite nicely. A little bit of a scrub and a dry. Interesting, this one doesn't have an EAR logo on, not quite sure why. We'll put that in the end position. So now we'll flog on and do the rest of them. Now I'm going to clean up the channel strips, and as you can see again, they are pretty filthy look. And to do that, I'm just going to use some Amber Cleanse foam cleaner. Any foam cleaner will do. You just spray it on the top, comes up in foam, and then I'm just going to use some tissue paper to wipe it off, and that'll be good enough for a first pass. Okay, here's one after the initial cleaning. I should probably do a little bit more when the mix is all fully back together. Use a cotton bud maybe to get into some small crevices, but that's a lot better than it was. I'm also going to have to service all of these pots and switches using some contact cleaner. The next thing to do is to go through each one of these valves and to test it to make sure that it's working. If you remember, channel 1 and channel 6 are not working. They've labelled the channels, which is useful: 1, strangely, 5, 6, 3, 4 and 7, 8 over there. I think 2 is probably somewhere, must be here somewhere. Yeah, I think 2's this one here. A bit weird that I've done this. Anyway, to do that, I'm going to put each valve on the orange valve tester here, and then just press the old button and it goes through its sequence, and it comes up either good, worn or fail, and that takes about I don't know, a couple of minutes to go through its sequence. So we'll pick it up now towards the end of the sequence. Yeah, it's coming to the end now, look, and it's come up with a good, and that's passed. This light shows you, there's usually 2 lights here, like 8 and 9 or something, and that shows you what each half of the valve is doing. So one's got a gain of 8, one's got a gain of 9, for example, but with one light on it shows you both halves of the valve are exactly identical. In other words, in this case they're both 8s. So that's good to go. So now I'll just plough through and do the other 39 valves. I'll see you in about 10 days. Okay, it's been several weeks since I looked at this project, so I'm going to pile into it again. And the first thing I want to do is to replace this chain, daisy chain of 0.22 ohm resistors here and here with a 1 ohm resistor, 25 watt for each one. Now, because of the way this has been designed and built, there's no clearance here whatsoever. Don't forget the top panel goes on here, and yeah, there's a thickness of a sheet of paper between here and the top panel, so we can't put these here. So I'm going to put them onto this back panel here on the inside, and then take a couple of wires up across here and here, and that will sort out this mess. Then we can have a little think about this later on. So that's the plan. This is all very bent. Basically everything is wrong with this. It's the material's not thick enough for the weight of this amplifier, so it's all got completely bent. So I might have a go at straightening that first. And I've made myself a little template here. It's easy to make a mistake and put this resistor on the outside and center pop through and then drill through, and you find actually that it's wrong. You need the holes here and here. So I'm going to make this template and then just literally turn it upside down and then mark through these dots here, there and there, and then that's a, and mark this out, so there's a proper template for the resistors. And I'm just going to center pop a couple of holes there, there and there, drill them through, and then yeah, take it from there. So let's do that. I'll get straightening this first if I can. Not sure I can. Anyway, that's the plan. So we want it sort of here. And sort of here. There we go. Now we can just drill a couple of pilot holes through there and then enlarge them. Okay, I've drilled the 4 holes. Interestingly enough, that center punch didn't touch that. I had the magnifying glass out on the chassis. I couldn't see the slightest indentation, so I had to mark through with a felt tip pen and redo that. Amazing. So what we'll do now is I'm going to solder a couple of wires to here and sleeve it, and then I can put this in here without having to worry about trying to solder onto that later. So let's do that. There we go, no need to show you all the others. That's going to go there, and the wires are going to come up here. So let's get the other 3 pieces of wire on, and then we can bolt these in. There we go, we've got the 2 25-watt resistors, 1 ohm, with some longer than needed leads on there. And now we can bolt them to the inside here and bring these leads up and dispose of all this lot. That'll be one nice bit of tidying up done. Not particularly easy to put these nuts and bolts on here. Just due to the difficulty of getting your fingers in. This is the easy one. I won't do that up too tight yet, and I'll see if I can get the nut in on the back of this lower one. I've got a little couple of tricks for doing that. Do the holes line up first of all. Good Lord, a miracle. Now it's very, very difficult to get the nut on the back of that lower I might just about be able to get it on there with a pair of pliers. Let's see if we can put the washer on first. Yeah, that's on. Now, I might just be able to do this. Dropped that one. Try again. Yes, got it, good. Good, that's one power resistor in. Yeah, good. So we have one in there, and then these wires will come up just up here like this. One will go to here, and one will go to here, and we'll chop all these four out. So I'll just get the other power resistor in now, which I think is slightly easier than this one. I did manage to bend that a little bit, so we'll put that one in there like that, and then we're ready to wire up. Okay, that wasn't particularly easy getting those in there, just because of the difficulty of getting the nut on the back of the resistor there. So now we're going to take these two wires up to, we think, yeah, it's just a hideous daisy chain this, up to here and here, and just to make sure I don't make any mistakes, I'm just going to mark those two spots there to remind me. And now I'm going to take out this daisy chain. There we go. And that's that gone. 4.22 ohm resistors in series with each other, making 1 ohm. So I'll bring one wire to here. Been snowing today. It's still November in the UK, and we've had an inch of snow in Berkshire. Rather amazing. So that goes onto that, and this one will go up to here. It's already looking a bit neater. Absolute flipping. I won't say anything more. Right, there we go. That's to there. At some point, I'll put a little bit of hot melt glue on here just to hold those down. But that's good. Now we can do the same with these pinks. Look, which is the other 1 ohm resistor, and here's the daisy chain here. So again, we'll do the same trick. We'll just mark the spots there. Very easy just to make a mistake. You take this out and think, oh no, where did it go? Did it go there? Or it was, suddenly you've got this horrible sinking feeling that you're not going to be able to get back to square one. Lots of black sealant everywhere. Yuck. There we go. And so one goes to here. like so. And the other one goes to here. See how easy it would be to forget where that came from if I hadn't marked that up. That's a lot neater. Good. And at 25 watts, those resistors are well overrated now. So good, that's good as well. So again, we'll tidy that up a bit at the very last minute. Right, that's fantastic. I'm pleased about that. We've got rid of all this gubbins here. Look, ugh, these are all broken as well. So that's a good job done. Chuck those in the bin. And we can now move on to some of these other resistors. This, I'm not quite sure what I decided to do about this. It's been a while now, but something has to happen here. We've got these 15 ohms in series here. Again, it's this daisy chain idea. 3 15 ohm resistors. So it'd be nice to have a 47 ohm 25 watt. And do the same trick there. Maybe on this front panel here. Anyway, I need to have a little think about that. Right, here we are again after a few weeks break on this EAR power supply. I've got now in stock some 25 watt 47 ohm resistors. There they go. And I'm going to replace this resistor chain here, all broken, daisy chain here, 3 15 ohms in series with this 25 watt 47 ohm. And I'm going to put it on this panel here, obviously on the inside. A little bit tricky to get in there, but I think I can do it. And to do that, it's sort of going to go there, but on the inside. And I've got my little template here. You'll notice that's the opposite to that, which is what you want, because when I drill through here, this is going to go up on the other side. I made that mistake many times in the past. Right, so let's get cracking and drill our hole in here. It's not going to be very easy to get the resistor in there, actually. Yes, I can just squeeze it past the board here by flexing this out, and it'll just go past there, so that will allow me to get it in. And then getting the nuts on the other side will be difficult, but I use the old trick of gluing the nut to my finger with a little bit of Bostik, and then you can have the nut and you can just actually put it in and feel around on the inside. So I want it about here, which is kind of about there. So there we go. Right, so I can drill those holes and get that fitted. Okay, there's the two pilot holes. I'll just open those up now to I think 3.5 mil will do. Okay, the next thing is to attach our two wires to the resistor so that we don't have to try and do that. like that. So I'm just going to do that with the other wire now, solder that, and maybe put a little bit of sleeving on there, and that's ready to go inside. Right, that's the wires on, and now we'll just put a little bit of sleeving over, like so. Trusty old heat gun. And that's now ready to put inside. So the tricky bit now is to joggle this in and to get the nuts and bolts on. So let's have a go at that. Well, you wouldn't flipping well believe it, but would you believe that I've made a mistake again on this? This is the wrong way round. This fits here, and of course once you go the other way up it's opposite. And I realised my template I've made here, I've got an inside and an outside. I hadn't realised I'd done that, and I just put the template on and marked through there, thinking that was the template. So actually, once again, I've ballsed that up in terms of getting that right. Annoying, that. Very annoying. So I'm going to have to do all this again. Plus we get left with two holes in the chassis, but I think I'll just put a nut and bolt in each of those and make that look a little bit better. Not, this chassis is incredibly tatty anyway. I've sprayed the front panel, or the top panel of the chassis, and that's actually come out quite nicely. I'll show you that. There you go. So I've sprayed that up. That was really horrible. I found a matching colour. It was kind of like that on the outside. So that's better. And we'll just put some nuts and bolts in there just to make that look a little bit neater. Annoying. So here we go again. I'm going to drill those holes out again. Right, there's the holes in. So the moral there is, it doesn't matter how many years or even decades in my case I've been doing this sort of thing, you're still subject to making balls ups. Anyway, won't be the last time I do that either. So now we see if we can get this in with an M3 bolt. It's a little bit short, that. I think I'll go the next size up. Okay, that's good, and that hole there lines up as well, so that's good. So I think the first thing to do is see if we can get a nut on the end of here. Not very easy down in here. Can I get my finger in? Oh, that's difficult, that. I think with a pair of pliers maybe I can get the nut and washer on there. Let's have a little go. This is going to be quite tricky. I don't think I'll inflict all this on you. That's got it. I'll just leave this in just to show you how tricky some of these things are, really. Good. Right, that's that one on. And the other one. So now we'll put the bolt in, and yes, I can get to that with the old nut glued on the finger routine. I'll do that to show you. So a little blob of glue on the finger. The trick here is to put your finger in and feel where the bolt is hitting your finger. Is it kind of there or right at the tip? And in my case it's kind of there. And if you go gluing it to the end or something, you'll find you can't get it in there. So I'm just going to let that glue dry, and then hopefully we're going to be able to get in there and put this on. Okay, here we go. So I'm going to go in here, and where's my screwdriver here? Right, I'm going to see if I can find it. It's not easy with a nut on the end of your finger. I think actually that's got it. So that went well. I just got there immediately. Quite often you can mess around for quite a while. Nice little technique that, I think, don't you agree? You'd never do it any other way. Okay, the resistor is in, so now it's a question of soldering it to where this daisy chain of resistors is. So one is going to go to here and the other one is going to go to here. So I think we can, well, I just want to be very cautious here. I don't have a schematic for this amp at all, or sorry, power supply at all. So I'm just going to, I'm not going to make a mistake here, but I just want to doubly make sure I know where those ends of this resistor chain are. So that's going to go to there. Sort of thing that can happen is you can get interrupted. You know, the telephone might go now and I go away and then come back and think, oh crikey, where did that come from now? So you just learn to be kind of ultra careful. As careful as I was putting that power resistor in. That's how careful I am. Real attention to detail man, me. Right, and then here's it's all glued on with this kind of black plastic, black gunk. This is probably roofing mastic or something, this. So that comes off there, and that goes to there. And that's a lot neater, I think you'll agree. I mean, this is all taking time, but I mean, look at the state of this. This is all broken, look, here. See, that's even exposed the insides of the resistor there. This one's crumbling. And the reason they're crumbling is because, of course, they're underrated. You know, I think these are 3 watt resistors, and they're probably taking 2.7 watts each or something, you know. And so they've just got hot over the years. We've now got a 25 watt resistor in there. Way more like it. That'll never go wrong. Now I'm tempted to call it a day on that power supply. We've done a fair old bit. We've replaced those 3 resistor chains. This one's a little bit chipped here, but it's actually okay. Just a little bit chipped off the corner, and these 2 look okay. So I'm kind of tempted to leave well enough alone there. And proceed now with, I think the next thing to do is to power this up and make sure we still have the voltages we're supposed to have. And then, then I'm going to plug it into the mixer again and see what's happening on the mixer side. But I'm happy about that supply now, and with this new lid, it'll look a lot nicer when that eventually goes on. Right, I decided to spend a few hours drawing up the schematic for this, because I think it would be useful for the customer to have the schematic and useful for future people. And it's a bit of a mess, to be honest with you, so I couldn't work out what was going on, and so I decided to do a schematic. Here are my rough notes. So that's page 1, there's page 2, and that's the main situation. So I'm going to draw that up properly, and I'll show you that when I've done that. But what I thought I would do is, if you remember, the royal we made a mistake on these holes here. You probably can't see, but this hole here, the aluminium clad resistor is behind it, so we can't just put a nut and bolt in there, whereas this one is free. So I thought I would put a LED in there. There's no indication on this power supply that it's on. There's no lamp, of course, nothing. So I'm going to put an LED in there and wire that up to the 27 volt heater supply with a suitable drop-down resistor, and that will block up one of the holes, and I'll just fill the other one up with a bit of araldite. The other thing that's a mystery on this amp at the moment is the mains switching situation. The mains comes out of the IEC socket on here and goes off up the umbilical and comes back down the umbilical to power this power supply. Almost as though up in the mixer there was just an on-off switch, which is exactly what I'd expect. But I cannot see an on-off switch up in the mixer at all, so at the moment I've just got it looped out here, so that's a mystery. The other thing I don't like, and I'm going to do a bit of work on, is the earthing on this. You won't be able to see terribly well, but the IEC main socket earth comes in and just goes to this screen on the toroidal mains transformer here. And initially I thought, well, there's no earth on the actual chassis. But there is, if we go onto the back of the IEC mains and onto here, the chassis, it is actually earthed. But there's no earth coming off there going to the chassis. So I think it's just picking up on the body of this IEC mains socket here, and that's how the earthing is happening. I don't like that at all. So I'm going to take a proper earth tag down somewhere on the base here and just hardwire an earth back up to there. And that will keep me happy. Right, so that's what I'm going to do. Let's get the LED in and see if we can get that working, and then we can do the rest of the bits. Okay, the actual diameter for this LED is 4.8 mil. I don't have a 4.8 mil drill, so I've drilled 4.5, and that's too tight. So I want this to be a very tight fit. I'm going to put a blob of araldite on the back of it. I want it to be quite a tight fit so that the slightest push on there doesn't just pop this back into the chassis. It's quite well protected by this handle, which is good. So I'm just going to spend a bit of time filing this out carefully to exactly the right size for that LED. Okay, there's the LED fitted in and glued. And I've put a blob of araldite in that hole there to cover that. It's not pretty, but none of it's pretty anyway, so I'm not overly worried about that. I might try and get some paint to match this and mask all this off and give it a blow over. I'm not quite sure yet. It's pretty disgusting at the moment. So the next thing to do is to get that LED wired up. And here are the two wires. I'm simply going to take this to the 27 volt supply with a suitable resistor. I want about 10 milliamps through the LED. There's 27 volts here. Let's call it 2 volts across the LED. So I want to drop 25 volts at 10 milliamps, which is 2.5k. So if I put a 2.7k in there, I think we'll be good to go. So I think I'll do that and turn on, see if the LED comes on. Negative is here. And the positive we want to go to here, but via a 2k resistor, so I guess we'll just do something like this. Like so. Right, I think at some point I'll maybe put a bit of hot melt glue on here to hold this down. Let's just turn it on for a moment now and see if our LED comes on. There we go. Look at that. How nice is that? At least now we can see the power supply is on. Now we have to carefully discharge this lot because there are 3 supplies here. I don't really understand what's going on with this power supply actually. I will show you a bit more detail when when I have drawn the schematic up, but very briefly we have, apart from the heater supply, the 27 volts DC, which we understand, we have these other two supplies. So we have 380 volts between pins 1 and 8, and 200 volts between pins 8 and 7, and 580 volts between pins 1 and 7 on the umbilical. I have no idea what those supplies are for. Okay, I've drawn up the schematic, and I thought I'd just talk you through it because I think you might find it interesting. Excuse my old-fashioned electrolytic capacitor nomenclature, that's what I grew up with. I think it's changed now. So we have three separate power supplies in this one box. We have the heater supply that supplies all the heaters for the several dozen valves there are. We have what I call HT1 and what I call HT2. Let's look at this heater for the moment first of all. I think you'll find this interesting. Primary, obviously. Here's the first secondary. 21 volts AC, and it goes to a socking great big 10 amp bridge rectifier to rectify it to produce 27 volts DC. Now look at the smoothing that this designer's put on this. So we have 4,700 at 35 volts here. I've just drawn one. Then we have this ripple reduction power resistors. These are the resistors that we changed some of. And then it goes, there's a discharging resistor here to discharge these capacitors, don't worry about that. And then we have another 4,700 at 35 volts, in there. Then we have a bit more ripple reduction. Again, these are some of the resistors we changed. And then we have a 10 off 4,700 at 35 volts. So all in all, we've got 19 4,700 microfarad capacitors at 35 volts, giving a total capacitance of 89,000 microfarads for our heater supply. I have no idea why he wants so much smoothing. A couple of these here, a bit of ripple, a couple of those there would have done fine. Don't know. Completely, I don't understand it. Never seen anything like it. Okay, now onto our HT1. So again, another winding on the transformer, this time 274 volts AC. He's rectified it this time with 4 discrete 5 amp diodes in a bridge to produce 380 volts DC. Now this is a much more sensible power supply in my view. We've got 400 microfarads at 400 volts, bit of ripple reduction, that's the 47 ohm that we put in. Bit more ripple reduction, bit more smoothing, 400 microfarads at 400 volts. Bit more ripple reduction. We didn't change those were two of the good ones. No, actually tell a lie, those were the two twisted together 2 watt 100 ohms that I put in. Then a bit more smoothing, 2 more 400 at 400 volts. So we've got a bit of an overkill in my view, but we've got 1, 2, 3, 4, 8, 1600 microfarads at 400 volts. Bearing in mind the average guitar amplifier, you'd have a 22 microfarad there, maybe a 47 microfarad, maybe a 22, maybe another 22 microfarad. So you wouldn't even be getting up to 100 microfarads, and he's got 1,600 microfarads in this HT supply. Again, there's a 4 meg 7 in there. I think it's just to discharge this lot when the power supply is switched off. That gives us an HT of 380 volts there. I kind of understand that. That's going to be doing all the preamp tubes. 380 volts is about right for that kind of level. A bit high, but that's fine. Now we have the mystery supply here. Here we go again. We've got 148 volts AC winding. Again, we've got 4 1 amp diodes, so this is obviously not intended to produce the same current that this one is with its 5 amp diodes. It's upside down look, so that the positive of this supply is going up to here, and a negative is going down to here. So basically we have minus, with respect to this, minus 200 volts on this HT, or 580 volts across there. Standard power supply, 470 microfarads at 250 volts, bit of ripple reduction, 470 microfarads at 250 volts. I haven't a clue what this supply here is doing, this minus 200 volts. I would have thought all we would need for this amp is something like that, but there we go. That's it, that's a walk through the power supply. Now, prior to that little chat, I unplugged this power supply from the mains. However, you'll notice the light's still on. That is because we have nearly 100,000 microfarads of smoothing on the... Ooh, something blew up there. Whoa. So what that was... Okay. Something discharged with a bang. Yeah. However, the light's still on the front, which just means I have to rethink that light now. Here are some of the 4,700 microfarads in series. Look, in parallel. 1, 2, 3, 4, 5 there, 5 there, 4 there. So this is the 27 volt supply here, which supplies the heaters. And if I put the meter on it, you'll notice it's still got 5 volts on it. And I did add a 120k resistor here actually, just to kind of slowly discharge this lot. I might make that a little bit smaller to discharge it a bit quicker. I'm surprised that LED is as bright as it is actually, with I've got 5 volts across it. It is slowly discharging, but this 120k resistor I don't think is big enough. If we look up on the HT side of things, still got 91 volts there, look, on the HT. 91 volts there, and the other HT's over here, it's here and here. .45 volts still. So these are all gradually drifting down. Okay, I found out what the bang was. It was these 200 ohm resistors in parallel producing a 47 ohm resistor, which links one set of the HT caps to the second set to give a bit of smoothing. This is ground, this is HT, and it's arced from the ground to the resistor. So I just need to be a little bit more cautious with that and make a slightly better insulated job there. Quite surprised that arced across there, but it did. So that's the problem with that. So I'm just going to remake that completely in a more insulated manner, and you'll see what I've done. Okay, I've tidied this up now. I've put a bit of rubber underneath there and spaced those equally between those two terminals, and there's quite a big air gap there now. That'll be fine. I've also put a little bit of insulation on the exposed ends there. I also, whilst I was at it, decided to sleeve these. This is the LED light going over here, because this passes over this high voltage area, and there's a possibility of arcing across to this lead. And also this is the one of the anti-ripple resistors we put in, and it comes off the live here. Look, crosses over the ground. Here's a ground plane, crosses over there before going off to the resistor and back. So I thought, let's put a bit more insulation on there as well. So I think that's good to go. I think we can power up without too much worry about it. Arcing again, let's try that. Good. Last time I did that off camera, it just went bang immediately and arced across on these resistors here. You can see that point there, arced down to the ground. Good. I mean, in a million years I'd never design a high voltage power supply like this. It's an absolute abortion. But it's what we've got, that's what we're working with. So short of completely relaying this out in a more sensible fashion, which will cost a lot of money, I don't think we want to do much more. So I'm fairly happy with that power supply now. I'm going to put the lid on, but oh no, I've got to do the earth yet. I remember that earth thing, but I want to put some yeah, gosh, I've just noticed this here. Let me zoom out a bit here. I was going to say that I want to put some insulation in this lid here, which I will, because obviously this is grounded and this is like a couple of millimeters from all this high voltage stuff. But you can see that he's bodged something in here, a little blob of roofing mastic with a little plastic end of a biro or something, and that's designed to hold off the maybe there was one there too, to hold off this lid from the high voltage components, probably onto these rubber sticky feet here, not totally sure. Anyway, we'll have a look at that at some point, and I might just line this completely with some insulating material. I'm not totally sure yet. Don't like this at all, but anyway, no point in my keep saying it. So we're good. This LED is not brilliant. Of course, it shows you now that the power supply is on, but when I unplug it, you know, there unplugged, it stays on, which is you know, at least it's safe. At least it's safe like that. You think the power supply is on, and that will gradually. The reason that's staying on is because we have 100,000 microfarads of smoothing here. You could you know, you could heat your home on that for 6 weeks without even plugging this in. And I have put a resistor. Where is it? Here. I put a couple of resistors here to bleed off that 27 volts. We've got about 2.7k in there total. So that just shows you 27 volts, 2.7k. You know, it's not dissipating this voltage in any significant way. In fact, if we measure it, it is still, should be 27, it's now 18, 18.1, 18, 17.9, 17.8, 7, 6, 5, 4. So it's gradually going down as these resistors bleed off the voltage. Look, so yeah, that's going down like that. So after 2 or 3 minutes, that will actually you know, dissipate. Yes, I think I might put a smaller resistor still in there, just so that this bleeds away a bit more quickly. 13 volts, look. So it's down to half, and the LED is just as bright as it was, you know, at 27 volts. Right, a couple more little jobs to do. Smaller resistor in there. I can't put too small a resistor because it'll get too hot, you see. I don't want to start putting a power resistor in there. I don't know, maybe we could put a 2 watt 1k or something. Yeah, I'll have a little think about that. But I just want to do this earth thing before we go too much further. Again, I've just been looking around it. I don't like it. This PCB has a kind of earth plane here. It goes all the way around and is ostensibly earth. If I put a meter from there to chassis, you know, I get a kind of a short circuit. But the only reason that is earth is by virtue of these screws here. And yeah, that's not a very good way of getting earth, just screwing that down onto this pillar here. So I want to take a bond from there, an earth wire, back to the IEC mains input, and another earth wire to bond it properly to the chassis here. And I think we're okay on, I don't know, maybe, no, see, I'm not really very keen on this either. You see this chassis here, this top, this is relying on being earthed just by the fact of the screws going through here into the, you know, into the side here. But this is all painted. You can't rely on that kind of earth, particularly as this is what's going to go live if any of this HT stuff touches here. So again, I'm afraid I think I'm going to take an earth wire from somewhere, if I can do it surreptitiously, bond it on properly on the inside of here, and then take it off to the same earth point. And then if anyone eventually takes this lid off, they'll have to just undo the earth strap from here in order to get this lid off completely. I'm just not happy having a painted lid picking up its earth. Well, it just wouldn't pick up the earth. It's not very good at all, that. I don't know, very, very poor safety practice. Right, so that's what I'm going to do, and then finally I'm going to put something on the inside of here. I'm not quite sure. I think I might get rid of this blob of stuff here. Put just a bit of plastic on there, celluloid or something, and then that will just prevent. I mean, these equipment feet here are doing a reasonably good job of keeping this from touching the inside of there. But we've got 500 volts kicking around here. It doesn't take much to arc across to this ground here. That's the plan. I'm not doing any more tonight now. It's getting a bit late, so I'll do that, and then we'll wrap up this video as part 3. Okay, I've drilled an extra hole in here, and then I've cleaned off using a Dremel the inside surface there. So I'm just going to put a nut and bolt through there with a star washer on and a solder tag, and that'll give us a good earth bonding on here. There we go, just a little nut and bolt through there, and that's bonded on nicely. Now I can attach an earth lead to there. That gives a proper earth for this chassis top. And I've done the same on the underside of the chassis. I'm going to put another earthing point there on the inside, and then we can get some nice earth bonds. Okay, we've nearly finished the earth scheme. The earth comes out of the IEC mains socket, goes down to the chassis here, comes up to the printer circuit board on this wire here, and then this is going to go to the case. Now I'm going to double insulate this with a piece of sleeving. Let's get that the right kind of length. And the reason for that is that with all this high voltage floating around here, when we put the case lid on, I don't want this kind of, lying like this somewhere. Imagine the lid's on now, it's all dark in here, and this earth lead is just lying across the HT like that. 500 volts there, and there's not much insulation there, it could arc across. So I'm just going to put another piece of sleeving on here just to prevent that from happening. Right, so that's now double insulated, and that will be fine now in terms of any kind of arcing. Good. I'm not going to attach this to the case lid yet because I want to get this onto the mixer, get it powered up again, get the mixer working again, leave it on for an hour or so, and then just see how hot these various resistors are here. These 25 watts will be perfectly okay there. Just want to check how hot these are getting, and it'll give the supply a good old test as well, leaving it on for an hour or so. So that's the next thing. We're done on this, I think. Done the earthing, haven't done the insulation on the top, I'll do that last. Yep, we're good to go. So next thing is to get this back on the mixer, get the mixer powered up again, and seeing if we can find out what's wrong. I think last time I looked at it there were 2 channels that weren't working and 6 that were. So our next job is to try and sort that. Okay. Not quite done yet. I had a word with the customer about this business of there's no on-off switch on the mixer, and yet for this power supply to work, the live comes out of here, goes off up to the mixer, comes back down and turns this on. And he remembers that all you ever did was to plug in the IEC kettle lead here and the mixer came on. So what that tells me, I haven't checked this, but that tells me that at the mixer end it's just short-circuited instead of having a switch. They're just connected together. Not quite sure why. Maybe there was a switch, maybe they intended to have a switch, I don't really know. So what I'm planning to do then, I don't really like just plugging in a mains lead and it all comes to life. I'm going to put an on-off switch on the actual power supply itself. I'm going to put it about here. That's the only real place it can go inside, and then at least we can turn the power supply off and on. So that's the next job. We'll get this switch mounted. Okie dokie, that's the hole drilled, 12mm. Switch goes in nicely. So I'm going to put a couple of leads on here and then put the switch in, and I can wire it up on the inside. Not particularly easy to get the switch in, so that's why I want to put some cables on now. So let's do that. There we are, a couple of longer than necessary leads added to that. Now I can attempt to joggle this in from the underside. I won't video that because that will take me some time. It's quite tight in there. So I'll do that and then we'll wire it up and test it. Right, there's the switch mounted and wired in. Being British, off is up, which is not the American system. I think the American system is better. If you get a shock and you fall, you would knock the switch off on your way down. So here we go, let's turn it on. Nothing. Okay. That's a good start. Oh, I know why. Yes, I know why. I still need the shorting link from the mixer. Let me think, what shall I do? Shall I leave that in? So let me just show you this again. The live goes out on the umbilical up to the mixer on pin 4 and back on pin 5 through the fuse and back through the primary. I've just put a switch in here basically, dump, dump, and of course still requires that shorting there. I've measured on the mixer side now and that is indeed shorted to there. Don't know what's going on up at the mixer, but that's short circuited to there. So I think I'm just going to effectively just link this across here down at the power supply end. It's shorted up at the mixer end, I'll link it here. Otherwise when we turn it on, the power supply won't come on unless the mixer is connected. And yeah, I don't see why that should be the case. I don't see why we should have the mixer connected to be able to turn the power supply off and on. Yeah. Okay, I've done that. I've just linked that to that down at the power supply end, and it's linked up at the mixer end as well. And now that enables us to turn it on, hopefully. There we go. Nice light, nice on-off switch, and finally we can tell whether the power supply is working, and we can actually turn it off and on, which I think is a slight improvement. Good, we are now definitely done on this now, and I won't do an outro on this. Thank you very much indeed for watching part 3 of the Esoteric Audio Research mixer project. Next time you join me, I will be connecting this back to the mixer again and seeing if we can get those other 2 channels working. We've got 6 out of 8 working at the moment, and hopefully we'll be able to get the other 2 working. Thanks for watching, and I'll catch you on the next video.